The GAM-63 RASCAL was a supersonic air-to-surface missile that was developed by the Bell Aircraft Company. The RASCAL was the United States Air Force's first nuclear-armed standoff missile. The RASCAL was initially designated the ASMA-2, then redesignated the B-63 in 1951 and finally redesignated the GAM-63 in 1955. The name RASCAL was the acronym for Radar Scanning Link, the missile's guidance system. The RASCAL project was cancelled in September 1958. Development. During World War II, Nazi Germany air-launched 1,176 V-1 missiles from Heinkel He-111 bombers. The United States Army Air Forces, USAF, studied this weapon system. Testing was conducted in the United States using B-17 bombers and the JB-2 Doodlebug, a locally produced copy of the V-1. Successful testing of this combination led to the release of requirements to the aerospace industry for an air-to-surface missile on July 15, 1945. In March 1946 the USAF began work on Project Mastiff, a nuclear-armed air-to-surface drone or self-controlled air-to-surface missile. Northrop Corporation, Bell, and Republic Aviation were invited by the USAF to submit proposals for Mastiff. Bell was awarded a feasibility study contract by the USAF on April 1, 1946. Bell studied the feasibility of developing a subsonic pilotless bomber carrying a substantial payload over a distance of 300 miles, 480 kilometers. After 18 months of study, Bell concluded that rocket propulsion was not capable of providing the performance needed to boost the missile the AAF wanted to a range of 300 miles. The range requirement was reduced to 100 miles, 160 kilometers, 160.9 kilometers, but other technical problems surfaced. The USAF started Project MX-776. As a risk reduction measure, Project MX-776 was divided into two sub-projects. The MX-776A development developed the RTV-A4 Shrike, later redesignated the X-9 as a test bed for the RASCAL that would be developed under Project MX-776B. 22 X-9 missiles were launched between April 1949 and January 1953. Design. In May 1947, the USAF awarded the Bell Aircraft Company a contract for the construction of a supersonic air-to-surface missile compatible with the B-29 Superfortress, the B-36 bomber, and the B-50 Superfortress bomber. The missile was to have a range of 100 miles. Bell's development effort was led by Walter R. Dornberger. The RASCAL design used the X-9's canard aerodynamic configuration and a rocket engine derived from the X-9's rocket propulsion system. The RASCAL was larger than the X-9 with a fuselage that was 9 feet, 2.7 m, longer and 2 feet, 0.61 m, larger in diameter. The RASCAL's flight controls included forward and rear surfaces. Forward surfaces include fixed horizontal stabilizers and movable dorsal and ventral surfaces. Rear surfaces include wings with ailerons and fixed dorsal and ventral stabilizers. The aft lower stabilizer could be folded for ground handling. The RASCAL was powered by a XLR-67BA-1 rocket engine also developed by Bell. The XLR-67 provided 10,440 pounds force, 46.4 knots, of thrust using 3 vertical inline thrust chambers. All 3 thrust chambers of the XLR-67 were operated during the missile's boost phase, which could last up to 2 minutes. At the conclusion of the boost phase, the upper and lower chambers of the XLR-67 were shut down and thrust was sustained by the center chamber alone. Fuel for the XLR-67 included 600 US gallons, 2,300 liters, of white fuming nitric acid oxidizer and 293 US gallons, 1,110 liters, of JP4 jet fuel. The oxidizer was stored in a series of tube bundles instead of a spherical storage tank. It is believed this configuration was chosen because it weighed less than a spherical tank of the same volume. Propellant was provided to the thrust chambers by a turbine-driven propellant pump. A gas generator powered the propellant pump. The propellants were glow plug ignited. Bell contracted with Purdue University for the glow plug ignition system. Aerojet provided the pump drive assemblies. The GAM 63 used a command guidance control system where the RASCAL was remotely controlled by the bombardier in the launching bomber. The RASCAL guidance system was developed jointly by Bell, Federal Communications/Radio Corporation of America, RCA, and Texas Instruments. The initial version of the control system provided an accuracy or circular error probable, CEP, of 3,000 feet, 910 m. Adequate for a missile equipped with a nuclear weapon. The bomber carrying the missile was modified with an additional antenna and equipment at the bombardier's position needed to guide the RASCAL. During the flight to the launch point, the bombardier transferred wind and navigation data periodically to the missile. Prior to launch, the bombardier tuned a video relay receiver, altitude phasing, and adjusted the terminal guidance tracking indicator. Missile control surfaces were also checked to make sure they were functional. Prior to the bomber taking off, the RASCAL was pre-programmed for a given flight path. The bomber flew along a heading towards the target. A computer in the RASCAL tracked the aircraft heading and azimuth to the target and automatically dropped the missile at the launch point. After launch, a lanyard connecting the RASCAL to the bomber was used to start the missile's rocket engine. In the event the lanyard failed, an automatic timer would count down and start the engine. The RASCAL was air-launched above 40,000 feet, 12,000 m. After launch, the bomber turned away from the target. The missile would climb from the launch altitude to 50,000 feet, 15,000 m. Video providing radar imaging of the target would be transmitted back to the bomber. As the missile approached the target, the detail in the radar video transmitted from the missile improved. The missile began a terminal dive about 20 miles from the target. The command guidance system did not send a directional signal and was not encrypted, which made it susceptible to detection and jamming. An inertial guidance system developed by Bell was used in the later GAM 63A version of the RASCAL. This improved guidance system decreased the CEP of RASCAL to 1,500 feet, 457 m. This system received reference information from the bomber prior to launch. The accuracy claims of the inertial guidance system have been questioned by sources. This system could also be used to guide the missile throughout its flight to the target. The RASCAL's forward section was interchangeable for different targets. Using this capability, the RASCAL could be equipped with nuclear, biological, chemical, blast, or incendiary warheads. The requirements for biological and chemical warheads were dropped at the end of 1953. On December 5, 1949, requirements for the RASCAL called for a nuclear warhead weighing between 3,000 pounds, 1,400 kilograms, and 5,000 pounds, 2,300 kilograms. The RASCAL warhead compartment accommodated a cylinder 3.8 feet, 1.2 m, in diameter and 6.25 feet, 1.91 m, in length. The U.S. Air Force also wanted the ability to use the RASCAL as a standard gravity bomb if the missile could not be readied for launch. In January 1950, Bell began to study what nuclear warheads were available for RASCAL. The W-5 nuclear warhead was initially considered. On August 20, 1950, the Special Weapons Development Board, SWDB, authorized a W-5/RASCAL integration effort. The Atomic Energy Commission, AEC, was responsible for developing the fusing system for the RASCAL warhead. No provision was made for surface burst at this time. In April 1952, fuse development was shifted to Bell, which resulted because it was U.S. Air Force policy to make airframe contractors responsible for nuclear weapons fusing, since this system needed to be integrated with the missile's guidance system. Bell developed two complete fusing systems, airburst or surface burst. Then in March 1956, the W-5/RASCAL program was cancelled. In July 1955, the W-27 nuclear warhead was considered as a replacement for the W-5 for the RASCAL. U.S. Air Force requirements for the W-27 called for a 2,800 pounds, 1,300 kilograms, nuclear warhead with either electronic countermeasures equipment, infrared countermeasures equipment, or extra fuel to increase the range of the RASCAL. A design for the adaptation kit between the W-27 and the RASCAL was completed in January 1957 before the RASCAL was cancelled. 3 bombers were originally considered as RASCAL launch platforms. The B-29 was removed from frontline service while the RASCAL was in development. In March 1952, the U.S. Air Force then turned to the B-36 and B-47 as RASCAL missile carriers. The B-36 was assigned first priority for the RASCAL. The U.S. Air Force Strategic Air Command did not agree with the decision to use the B-47 to carry the RASCAL. SAC wished to substitute the B-47 with the B-50, proposing to field a single squadron each of RASCAL-equipped B-50S and B-36S. It was determined that RASCAL carrying B-50S would need to be based outside the United States because the B-50 would have less range while carrying the RASCAL. The decision to eliminate the B-50 as a RASCAL carrier was not reached until June 1956. A single B-50 was used as a launch platform in support of the RASCAL test program until 1955. A Cradle lowered the RASCAL from the B-50's bomb bay before launch. The first powered RASCAL was launched from the test B-50 on September 30, 1952 at White Sands Missile Range, New Mexico in the United States. In May 1953, 12 DB-36H Director bombers were ordered from Convair. Each bomber would be equipped to carry a single RASCAL missile. The RASCAL occupied both of the B-36's aft bomb bays where it was carried semi-submerged. A portion of the missile was located inside the aircraft and a portion of the missile hung below the aircraft. One forward bomb bay was used to hold equipment required by the RASCAL's guidance system. The retractable antenna for the command guidance system was installed in the rear of the aircraft. The first YDB-36H was flown on July 3, 1953. 6 captive carry flights were flown between July 31, 1953 and August 16, 1953. The addition of the missile to the B-36 did not increase drag or change the handling characteristics of the bomber. An unpowered RASCAL was dropped from a YDB-36H on August 25, 1953. On December 21, 1954, a DB-36H was delivered to the Air Force for use in the RASCAL test program at Holloman Air Force Base, New Mexico in the United States. By June 1955, at least 2 missiles had been launched from the B-36 and Convair had completed manufacturing modification kits for the 12 planned aircraft. 2 kits had been installed on B-36 aircraft when the U.S. Air Force decided to carry the RASCAL only on the B-47 bomber. Before the end of 1952, Boeing received a contract from the U.S. Air Force to modify 2 B-47Bs into prototype RASCAL missile carriers. A removable missile support strut was installed on the right side of the B-47. Extra internal structure was installed to support the loads of the strut and missile. While carrying the RASCAL, the B-47 could not carry other weapons. The guidance equipment for RASCAL was added to the B-47 bomb bay. The retractable antenna needed by RASCAL was added to the rear fuselage. Both aircraft were sent to Holloman Air Force Base to support the RASCAL test program. After completion of the 2 DB-47B prototypes, the delays in the RASCAL's development effectively placed the DB-47 modification effort on hold until March 1955. Then in June 1955, Boeing received a contract to modify 30 DB-47Bs to carry the RASCAL. The Strategic Air Command was concerned that externally mounting the RASCAL and the associated internal equipment needed to support the missile would seriously degrade the performance of the bomber. The performance impact was great enough to make the B-47/RASCAL combination of questionable value. SAC also argued the B-47/RASCAL combination might never work well. Since the equipment being added to the B-47 to guide the missile added more complexity to the already complex B-47. Then the modification costs required to carry the RASCAL added nearly $1 million to the cost of every B-47. To SAC these costs seemed premature considering the state of the RASCAL's development at that time. Finally SAC considered it unwise to commit aircraft and to start training crews before the missile's development had been completed. The U.S. Air Force then decided to use the B-47E as a RASCAL missile carrier. Boeing was contracted to convert two B-47E into YDB-47E aircraft. The first YDB-47E flew in January 1954. The first successful RASCAL launch from a DB-47E occurred in July 1955. Operational history. In early 1956, the U.S. Air Force limited DB-47E production to just 2 aircraft. In May 1957, the U.S. Air Force decided to field only 1 instead of 2 DB-47 squadrons equipped with the RASCAL missile. Strategic Air Command leadership believed the RASCAL was already obsolete. By December 1957, the U.S. Air Force 445th Bomb Squadron of the U.S. Air Force 321st Bomb Wing was training with the RASCAL. The first production RASCAL was accepted at Pine Castle Air Force Base on October 30, 1957. Funding shortages would prevent facilities from being built at Pine Castle Air Force Base until 1959. In August 1958, a review of the previous 6 months' RASCAL testing revealed that out of 65 scheduled test launches, only 1 launch was a success. More than half of the test launches were cancelled and most of the others were failures. On September 29, 1958, the U.S. Air Force terminated the RASCAL program. The AGM-28 Hound Dog replaced the GAM-63 program. The first flight tests of the Hound Dog were in April 1959, and the first operational Hound Dog was delivered to the U.S. Air Force in December 1959. The first Hound Dog-equipped SAC squadron reached initial operational capability in July 1960. The Hound Dog offered a weapon with nearly 5 times the range of the RASCAL, without command guidance, and without hazardous fuels to contend with. Variants: ASMA-2, RASCAL designation under the U.S. Air Force 1947-1951 designation system. B-63, RASCAL designation under the U.S. Air Force 1951-1955 designation system. XGAM-63, 75 prototype RASCALs, serial numbers 53 to 8195 through 53 to 8269. GAM-63A, 58 production RASCALs, serial numbers 56 to 4469 through 56 to 4506. Operator: United States. United States Air Force. Survivors: GAM-63, American Legion Post 170, Midwest City, Oklahoma, United States, registration required. GAM-63, Air Force Space and Missile Museum, Cape Canaveral Air Force Station, Florida, United States. This pristine artifact is in sequestered storage in Hangar R on Cape Canaveral AFS and cannot be viewed by the general public. GAM-63, Castle Air Museum at the former Castle AFB, Atwater, California, United States. XGAM-63, National Museum of the United States Air Force, Wright-Patterson Air Force Base, Dayton, Ohio, United States. GAM-63, on static display near the southwest corner of the Goddard Junior High Athletic Field in Midland, Texas. Type air-to-surface missile. Service history. In service October 30, 1957, planned. Production history. Manufacturer Bell Aircraft. Unit cost $2,262,000. Produced 1952. Specifications. Weight 18,200 pounds, 8,255 kilograms. Length 31 feet 11.5 in, 9.74 m. Diameter 4 feet, 1.22 m. Warhead W-27 nuclear. Detonation. Mechanism. Airburst or surface. Wingspan 16 feet 8.3 in, 5.09 m. Propellant Bell XLR-67BA-1 liquid propellant rocket engine with 10,440 lbf, 46.4 knots, of thrust. Operational. Range. 100 miles, 161 kilometers. Flight ceiling 65,000 feet, 19,812 m. Speed 1950 miles per hour, 3138 kilometers per hour. Guidance System. Command guidance with radar imaging, GAM 63, inertial guidance / command with radar imaging, GAM 63A. Launch Platform B36, B50, and B47.
Please subscribe and thanks for watching.